Hello everyone, today I'm going to talk about recursion. So what is recursion? Recursion is where a function calls itself directly or indirectly. Recursion programs would be used to solve smaller versions of the same problem. Recursion doesn't require iteration loops, they iterate through repeating calling themselves. So components of a recursion programming. It will contain a base case, which is the simplest case of which it returns a value and does not call itself anymore. This is important as it will not cause infinite loops and overflow. And we also have a recursive case where the case will call itself to iterate forward. So benefits and drawbacks of recursion. So the benefits include simple and concise code. Normally, writing in recursion will provide a very short lines of code and is great for looking. And the drawbacks is intensive on the memory, since every time you run, to calling the program again, you be put into the stack and you will be intensive on the memory. It's hard to debug since you have to repeatedly go through the loops. So let's talk about an example, which is the Fibonacci sequence. A Fibonacci sequence is defined as the next number in the sum of the current number and the previous number. So our goal is to create a recursion program that calculates the ith Fibonacci number with the first two numbers 0 and 1. Hello everyone, now let's write some code. So first we will define a function of the Fibonacci. So define Fibonacci and then this one input, so it's n. And then we need to set the base case. So if n equals to 1, since it is the first number, then we have to be 0. And then if n equals 2, then we'll return 1. And if this is then for the recursive case, you have return firstly the Fibonacci, the last number and the second last number plus together, and this is recursive since it calls itself. Let's try this by printing Fibonacci, let's say 5 or 4, and we get 2. So this is correct because our Fibonacci sequence is 0, 1, 1, 2. So this is the fourth number. And the next number will be 3, 5. Let's try 6 if it is 5. Yes, so this is correct. Another important aspect of recurring is memorization, which is storing the result of the recursion into an array, so that the next time you occur the recursion with the same parameter, you could use the result instead. This will speed up calculations and reduce memory usage in recursion. So for example, for the Fibonacci sequence, for every time we calculate the number, like the n-1, n-2, we can store it in an array. So when we calculate it again, because we have two recursions that adds it together, we could just use the stored value directly instead of going through recursion all over again. So this will really speed up the process. And that's all. Thank you for listening.